Hello everyone and welcome back to the gRPC course. Today we will learn how to use gRPC interceptors to authenticate and authorize users. So what is a gRPC interceptor? Well, basically it's like a middleware function that can be added on both server-side and client-side. A server-side interceptor is a function that will be called by the gRPC server before reaching the actual RPC method. It can be used for multiple purposes such as logging, chasing, rate limiting, authentication, and authorization. Similarly, a client-side interceptor is a function that will be called by the gRPC client before invoking the actual RPC. In this lecture, we will first implement a server interceptor to authorize access to our gRPC APIs with JSON Web Token, or JWT. With this interceptor, we will make sure that only the users with some specific roles can call a specific API on our server. Then we will implement the client interceptor to log in user and attach the JWT to the request before calling the actual gRPC API. Alright, let's start by adding a simple interceptor to our gRPC server. There are two types of interceptor, one for unary RPCs and the other for stream RPCs. In this gRPC.new server function, let's add a new gRPC.unary interceptor option. It expects a unary server interceptor function as input. We can press Command and click on the function name to go to its definition. Let's copy this function's signature and paste it to our main.go file. I'm going to name it unary interceptor. It has some input parameters such as a context, a request, a unary server info, and the actual unary handler. It returns a response and an error. Now we can pass this function to the unary interceptor option. Here we have to add the gRPC package name to the unary server info and unary handler. Okay, for now let's just write a simple log saying unary interceptor together with the full method name of the RPC being called. Then we just call the actual handler with the original context and request and return its result. We can do the same for the stream interceptor. Add gRPC.streamInterceptor option. Follow the definition to get the function signature. Copy and paste it to the main.go file. Pass that function to the stream interceptor option. Write the log with the full RPC method name. This time the handler will be called with the original server and stream parameter. Alright, let's try it. First I will start the server. Then I open a new tab and run the client. As you can see on the server logs, the unary interceptor is called 3 times for the create laptop RPC. This is the full name of that RPC, which includes the package name techschool.pcbook and the service name laptop service. Now let's enter Y to rate the 3 created laptops. This time on the server side, the stream interceptor is called once. Awesome. So now you've got some ideas of how the server interceptor works. We will extend its functionality to authenticate and authorize user requests. To do that, we will need to add users to our system and add a new service to log in user and return JWT access token. So let's create a user.go file and define the new user struct. It will contain a username, a hash password, and a role. We add a new user function to make a new user. We take a username, a password, and a role as input, and returns a user object and an error. We should never store plain text password in the system, so here we use bcrypt to hash the password first. Let's use the default course for now. If an error occurs, just wrap and return it. Else, we create a new user object with the username, the hash password, and the role, and return it. Next, we define a method on the user to check if the given password is correct or not. All we need to do is to call bcrypt.compare hash and password function, pass in the user's hash password and the given plain text password, and return true if error is nil. I will add one more function to clone the user. This function will be useful for us later because we're going to store users in memory. Alright, now let's create a user-store.go file and define a user store interface, just like what we did for laptop store and rating store in previous lectures. It will have two functions, one function for saving a user to the store, and the other function to find a user in the store by username. Now let's implement this interface with the in-memory user store. It has a mutex to control concurrent access, and a user map with key is username. I will write a function to build a new in-memory user store and initialize the user's map in it. Then we need to implement the save and find function of the interface. In this save function, first we acquire the write log. Then we check if a user with the same username already exists or not. If it does, we return an error. Otherwise, we just clone the input user and put it into the map. For the find function, we acquire a read log. Then we get the user by username from the map. If it is nil, we just return nil. Else, we return a clone of that user. And that's it. The user store is ready. Now let's implement a JWT manager to generate and verify access token for the users. The JWT manager struct contains two fields: the secret key to sign and verify the access tokens, and the valid duration of the token. These two fields should be passed as input parameters of the new JWT manager function. In order to work with JWT, I will use the JWT Go library. Let's search for it on the browser. Copy the GitHub link of the library and run go get to install it. Okay, now back to our JWT manager. The JSON web token should contain a claims object, which has some useful information about the user who owns it. So I'm going to declare a custom user claims. It will contain the JWT standard claims at a composite field. This standard claims has several useful information that we can set. But for the purpose of this demo, I'm just going to use one field, which is the expires at time of the token. As you might notice, the claim has a valid function that will automatically check if the token is expired or not for us when we call the parseToken function later. Okay, now beside these standard claims, let's add a username field and another field to store the role of the user. because we want to do role-based authorization. Next, let's write a function to generate and sign a new access token for a specific user. In this function, we first create a new user claims object. For the standard claims, I will only set the expires at field. We have to add the token duration to the current time and convert it to Unix time. Then we set the username and role of the user. We call JWT.newWithClaims function to generate a token object. For simplicity, here I use a hmark-based signing method, which is HS256. For the real production, you should consider using stronger methods, such as RSA or elliptic curve-based digital signature algorithms. The last and also the most important step is to sign the generated token with your secret key. This will make sure that no one can fake an access token, since they don't have your secret key. Okay, cool. Now let's add another function to verify an access token and return a user claims if the token is valid. We just have to call jwt.parsewithClaims, pass in the access token, an empty user claims, and a custom key function. In this function, it's very important to check the signing method of the token to make sure that it matches with the algorithm our server uses, which is, in our case, hmark. If it matches, then we just return the secret key that is used to sign the token. The parse function will return the token object and an error. If the error is not nil, we return invalid token. Else, we get the claims from the token and convert it into a user claims object. If the conversion fails, we return invalid token claims error. Otherwise, just return the user claims, and we are done. The next thing we need to do is to provide a new service for the client to log in and get the access token. Let's create a new authservice.portal file. The package and options are the same as in other portal files. We define the login request message with two fields, a string username and a string password. Then a login response message with only one field, the access token. We define a new auth service. It has only one unary RPC, login, which takes a login request as input and returns a login response. Alright, now let's run makegen to generate new codes for this service. As you can see, the authservice.pb.go file is generated. Just like what we did with the laptop server in previous lecture, I'm going to create a new authserver.go file to implement this new service. The auth server struct will contain the user store and a JWT manager. Let's add a function to build and return a new auth server object. Then we go to authservice.pb.go file to copy the login function signature. Paste it to our authserver.go file and make it a method of the authserver struct. This method is very easy to implement. First, we call userstore.find to find the user by username. If there's an error, just return it with an internal error code. Else, if the user is not found, or if the password is incorrect. Then we return status code not found with a message saying the username or password is incorrect. If the user is found and the password is correct, we call JWT manager.generate to generate a new access token. If an error occurs, we return it with internal status code. Otherwise, we create a new login response object with the generated access token and return it to the client. Okay, now we have to add this authentication service to the gRPC server. First, we need to create a new in-memory user store. Then we create a new JWT manager with a secret key and token duration. To make it simple, I will just define them as constants here. In reality, we should load them from environment variables or from a config file. For the demo purpose, let's set the token duration to be 15 minutes. Next, we create a new auth server with the user store and JWT manager. And we call pb.register auth service server to add it to the gRPC server. In order to test the new login API, we have to add some seed users. So let's do that. I will write a function to create a user given its username, password, and role, and save it to the user store. Then in this seed users function, I call the create user function 2 times to create one admin user and one normal user. Let's say they have the same secret password. Then in the main function, we call seed users right after creating the user store. Alright, let's try it. I will start the gRPC server, then use the events client to connect to it. When we call show service, we can see the new auth service with the login RPC in the result. Let's select the auth service and call the login RPC. Enter the username admin1. Let's try an incorrect password. The server returns incorrect username password as expected. Now let's call login again, but this time enter a correct password for admin1. The request is successful, and we've got an access token. Let's copy this token and go to jwt.io on the browser. Paste the token into this encoded area. We can see on the decoded area, the header part contains the algorithm HS256 and the token type JWT. The payload part contains the user claims with an expire time, a username, and a role. So the login RPC is working perfectly. However, we haven't written a proper interceptor to verify the token yet. So let's go back to the code and do that. I will create a new authinterceptor.go file and define a new authinterceptor struct inside it. This interceptor will contain a JWT manager and a map that defined for each RPC method a list of rows that can access it. So the key of the map is the full method name, and its value is a slice of row names. Let's write a new authInterceptor function to build and return a new authInterceptor object. The JWT manager and accessible rows map will be the input parameters of this function. Now I will add a new unary method to the authInterceptor object, which will create and return a gRPC unary server interceptor function. Then let's open main.go file and copy the unary interceptor function that we've written before. and paste it inside this unary function. It's exactly the function that we need to return. Similarly, we add a new stream method, which will create and return a gRPC stream server interceptor function. Then copy and paste the stream interceptor function here. Now, in the main.go file, we have to create a new interceptor object with the JWT manager and a map of accessible rows. For this demo, I will just write a function to return this constant map. Then in the gRPC.newServer function, we can pass in the interceptor.unary and interceptor.stream. Now for the accessible rows function, we need to prepare a list of RPC methods and the rows that can access each of them. To get the full RPC method name, let's open the terminal and run make client. Then in the server logs, we can see the full method name of the createLaptop RPC. So let's copy it. We know that all methods of the laptop service will start with the same path, so I define a constant for it here. Then we can create and return a map like this. The first method is createLaptop, which only admin users can call. The upload image method is also accessible for admin only. The readLaptop method can be called by both admin and user. And let's say that the searchLaptop API is accessible by everyone, even for non-registered users. So the idea is we don't put searchLaptop or any other publicly accessible RPCs in this map. Okay, now let's get back to the auth interceptor. We will define a new authorize function. We will take a context and a method as input, and will return an error if the request is unauthorized. Then in the unary function, we call interceptor.authorize with the input context and info.full method. If error is not nil, we return immediately. In similar fashion, for the stream function, we call interceptor.authorize with the stream context and info.full method, and return right away if an error is returned. Now let's implement the authorize function. First, we get the list of rows that can access the target RPC method. If it's not in the map, then it means the RPC is publicly accessible, so we simply return nil in this case. Else, we should get the access token from the context. To do that, we use a gRPC metadata package. We call metadata.fromIncomingContext to get the metadata of the request. If it's not provided, we return an error with unauthenticated status code. Else, we get the values from the authorization metadata key. If it's empty, we return unauthenticated code because the token is not provided. Otherwise, the access token should be stored in the first element of the values. We then call JWT manager.verify to verify the token and get back the claims. If an error occurs, it means the token is invalid, so we just return unauthenticated code to the client. Else, we iterate through the accessible rows to check if the user's row can access this RPC or not. If the user's row is found in this list, we simply return nil. If not, we return permission denied status code and a message saying user doesn't have permission to access this RPC. And we are done with the server authorization interceptor. Let's test it on the terminal. First, start the server, then run the client. We've got unauthenticated error with the reason authorization token is not provided. That's exactly what we expect. because we haven't logged in and add access token to the request on the client side yet. So let's do that now. As our client code is getting bigger and bigger, I will create a separate client package for it. Then create a new auth client.go file inside this folder. Let's define the auth client struct to call authentication service. This struct will contain the service field, which is the auth service client generated by Proto-C. It also contains the username and its password that will be used to log in and get the access token. As usual, we define a function to create and return a new auth client object. It will have 3 input parameters: a gRPC client connection, a username, and a password. The service will be created by calling pb.newAuthServiceClient and passing the connection. Next, we will write a login function to call loginRPC to get access token. Just like other RPC, we create a context with timeout after 5 seconds. Call defer cancel. Then we make a login request with the provided username and password. And call service.login with that request. If an error is not nil, we simply return it. Else we return the responded access token to the caller. And the auth client is completed. Now let's learn how to use it to build a client interceptor. I'm going to create a new auth interceptor.go file in the client package. The idea is we will intercept all gRPC requests and attach an access token to them if necessary before invoking the server. Similar to what we did on the server, I will define an auth interceptor struct. It contains an auth client object that will be used to log in user, a map to tell us which method needs authentication, and the latest acquired access token. What does that mean? Well, basically what we will do is to launch a separate Go routine to periodically call login API to get a new access token before the current token expired. So in the new auth interceptor function, beside the auth client and auth methods, we also need a refresh token duration parameter. It will tell us how often we should call the login API to get a new token. In this function, first we will create a new interceptor object. Then we will call an internal function to schedule a refreshing access token and pass in the refresh duration. If an error occurs, just return it, or else return the interceptor. Now let's implement the schedule refresh token function. But first we need a function to just refresh the token with no scheduling. In this function, we just use the auth client to log in user. Once the token is returned, we simply store it in the interceptor.accessToken field. Let's write a symbol here to observe later. Then return nil. Now in the schedule refresh token function, we should make sure to call the refresh token successfully for the first time, so that a valid access token is always available to be used. Then after that, we launch a new Go routine. Here I use a wait variable to store how much time we need to wait before refreshing the token. Then let's launch an infinite loop called time.sleep to wait. Then after that amount of waiting time, call interceptor.refreshToken. If an error occurs, we should only wait for a short period of time, let's say 1 second, before retrying it. If there's no error, then we definitely should wait for refresh duration. And the token refreshing schedule is done. Now comes the important part, adding interceptors to attach the token to the request context. Just like what we did on the server side, this time we define a unary function to return a gRPC unary client interceptor. Let's follow this to see how the interceptor function should look like. I will copy its signature and paste it here. This is the function that we should return. I'm gonna reformat it a bit. And add the missing gRPC package. Now inside this interceptor function, let's write a simple log with the calling method name. Then check if this method needs authentication or not. If it does, we must attach the access token to the context before invoking the actual RPC. So I will define a new function to attach the token to the input context and return the result. In this function, we just use metadata.append to outgoing context, pass in the input context, together with an authorization key, and the access token value. Make sure that the authorization key string matches with the one we used on the server side. Now come back to our unary interceptor. If the method doesn't require authentication, then nothing to be done. We simply invoke the RPC with the original context. The stream interceptor can be implemented in a similar way. Follow this function name to copy its signature. Paste it here with a return. Fix the code format. Add the missing gRPC package. Then write a log. Check if the method requires authentication or not. If it does, call streamer with the context that has been attached with the access token. Or else, just call streamer with the original one. And we're done with the client-side auth interceptor. Now let's open the client main.go file. Before adding the interceptors to the client, I'm going to refactor this a bit. Let's move this big chunk of code to a separate laptop client.go file inside the new client package. In this file, let's define the laptop client struct. It will contain the laptop service client object. Then, as usual, we define a function to create a new laptop client object. It will receive a client connection as input. Then use that connection to make a new laptop service client. Now we must turn this createLaptop function into a method of laptop client object and make it public with the uppercase letter C. We need to add .service here to fix this error. Then we do similar things for this searchLaptop function. This uploadImage function. And finally, this readLaptop function. All is done. Now let's go back to the main.go file. We have to change this pb.laptopServiceClient to client.laptopClient. Then call laptopClient.createLaptop here. We do the same things for all other test functions. I'm going to speed up the video to save time. Okay, now in the main function, here we should call client.newLaptopClient and pass in the gRPC connection. Now this is a bit tricky, but we're gonna need a separate connection for the auth client because it will be used to create an auth interceptor, which will be used to create another connection for the laptop client. So I've changed the connection name to cc1 and create a new auth client with it. To make it simple, I will define username and password as constants. Then let's create a new interceptor with the auth client. The refresh duration will also be a constant. Let's say for this demo, we will refresh it every 30 seconds. And we also need a function to define the list of methods that requires authentication. I'm just going to copy and paste them from the server interceptor and change this to a map string bool. Then change all these values to true. Alright, back to the main function. If an error occurs here, we write a fatal log and exit. If not, we will dial server to create another connection. But this time, we also add two dial options, the unary interceptor and the stream interceptor. Then we change this connection to cc2 and we're done with the client. Let's open the terminal and try it. First run the server. Then run make client. Oops, it says client is up to date. That's because make confuses our new client folder with the client command. To fix this, we must add it to the phony list in the make file. Actually, I'm going to add all of these commands to the phony list. Then back to the terminal and run make client again. This time we can see the token refresh and unary interceptor logs. And 3 laptops were created successfully. Let's enter Y to rate them. All successful. And we can now see the log for the stream interceptor. On the server side, we also see some logs for both unary and stream interceptors. And after a while, on client side, we will see that the token is getting refreshed as well. Before we finish, let's change this username to user1 and see what happens. As you might expect, we've got permission denied error, because only a user with the admin role can call create laptop API. So everything is working perfectly. Awesome! And that's it for today's lecture. I hope you enjoyed it. Thanks for watching, and I'll catch you guys later.